Hey PCWorld fans, Adam here with Frank Azor of AMD. Frank, tell the fine folks at home what your role is at AMD.
Hey everyone, I'm Frank Azor and I run consumer and gaming marketing for AMD.
Nice, okay. You're here for the gaming product. Specifically, we're going to talk about RDNA 4 and Z2.
Okay.
So, stuff close to my heart, and I think close to the fans out there. So much so that they were a little bummed that something didn't show up. I'm not quite sure. Anyway, sorry, I'm starting off with the serious stuff, but yeah, people are excited for the next generation of Radeon. I mean, we got some cards here. Can you just walk through the process of why it wasn't really kind of fully unveiled on stage at CES?
Well, first of all, I'll tell you that the cards are performing great, meeting and exceeding our expectations. There's no schedule delays, so we're on schedule. Those were not any factors as to why we did not bring RDNA 4 to our press conference on Monday. Look, it's primarily two things, real simply. One, we had an opportunity to wait and see what was going to happen from our competitors and to be able to respond to that, so we took advantage of the opportunity. And honestly, that's going to be good for the entire industry because it means that we're going to get more competitive products and we're going to get more value out there for gamers. So it's a win-win for everybody except maybe the competition, which that's okay. And then number two, and this is one of those behind-the-scenes types of things that it's maybe hard for a lot of people to understand, but we spend months preparing for these shows, and we have to balance how much time we have in the keynotes and all the content that we have to bring to it, and then how do we make sure that the content is, you should say, kind of like timed and polished so that it's engaging. It's not like we can go on and on and on and talk about a bunch of boring stuff, but we really try to put ourselves in the audience's perspective to make sure that what we're going to be communicating is what is going to be valuable for them to hear, not just what we think we want them to go off and hear. So as you go through that process, typically what happens is we start with, all right, here are the 7-8 things that we want to go off and announce. What's the right amount of content to be able to effectively announce this and give everybody what they want to hear around it? And we have a lot of different audiences too. You've got consumers, you've got gamers, you have all types of audiences, right? You have engineers in there, chip engineers, you have our own engineers that are looking at us at representing the products that they worked so hard to develop. So there's all these things you're trying to balance. Long story short, we had to launch, I think, like 4 processors. We had to announce our partnership with Dell. We had to do a little bit of AI PC talk as well. One of those processors that we announced, I think it was 5 processors that we announced, but one of them is our Strix Halo AI Max processor. A little bit of a lengthier story we need to tell there because it's amazing. It's disruptive, there's nothing else like it. So you take all of that into account and then you're like, all right, so here's everything we need to announce about RDNA 4, everything we need to announce about the 9070 cards, and we were talking about the RDNA 3 launch. Remember the RDNA 3 launch? We did a dedicated event for multiple hours. We went through all the detailed architecture. We show you why we made the decisions that we made, performance, and then we get into FSR and how does FSR work, what's the image quality that you're going to get from it, the performance, the ISV partners. We really had 5 minutes to do that in the press conference. And then we did it in rehearsals and things, and we're like, this is not going to be good. People are going to be upset that we did an entire graphics launch in 5 minutes of a 45-minute keynote, and then you're going to get the narratives like, oh, they don't care about gamers, and they spent more time talking about AI PC than they talked about gaming, and we're like, let's not feed into that. Like, let's just give it the time it deserves. We have the advantage of waiting and seeing what the competition does. So, yeah, the disappointment, I understand, but I also say to myself, it's cool that so many people are excited about it. That's also good. But yeah, maybe we could have handled it better. I don't know, but it is what it is. The good news is that the cards are running. We've got friends running the cards right now, playing games here on them.
Yeah, well, we got a couple models here. This is the 9070 and then the 9070 XT. Yeah, you've got multiple partner cards. I mean, I guess because it almost feels like it's a preview, like, oh, hey, we didn't talk about it at the keynote, we're going to have a dedicated event, but we still have the cards here, we still have them running. I think that was the confusing part.
It was important for us to let people know that there aren't delays, it's looking great, this is what you're going to be able to expect. So we tried to find a balance of how do we give you a little bit of confidence that things are going well and we're making progress and they're coming very soon, but how do we save a fair amount of news for the main event? Okay. And that main event's going to come soon. This is not like you're going to have to wait 6 months or 9 months. It's coming in weeks, the main event.
Okay. Well, I guess we'll have to wait for that then.
A little bit, just wait
You know what I
patiently.
mean? Be a little patient, I guess. Yeah. AMD Frank Azor says, be a little patient. I'm just kidding. No.
The most impatient man in the world says be a little bit patient.
No, I appreciate that. Okay, all right, I understand. Well, moving on to the goals of RDNA 4, can you tell me, like, from a high level, like, what are the goals that you're trying to achieve?
So what you can expect from the first two cards that we're going to announce in the RDNA 4 portfolio is you're going to see a little bit of improvement in rasterization, as you would expect, right? You're going to see a lot of improvement in ray tracing, and you're going to see an enormous amount of improvement in AI compute capability. And the reason we made those decisions is the library of ray traced games is finally, I would say, I believe, at a point where the value in investing in ray tracing hardware capabilities is you're going to extract that value for a significant portion of the games that are out there and that are coming out. We're starting to see games that are turning ray tracing on by default. So ray tracing's evolved in the last few years from being like a technology demo thing that you show off and you play at 30 frames per second to something that you may leave on all the time in a lot of games now. So we believe in developing cards that gamers value and that gives them features that they're going to make use of, not necessarily developing a bunch of features, putting a bunch of cost into a card that is just going to be like a great technology showcase, because that's cool and other companies do that really, really well. There's nothing to say that, I'm not saying that to criticize anyone around purchasing a card that does that. Those cards have their purpose and customers have options to go get those kind of cards and they're great solutions. But we need to have a different strategy if we're going to be effective. And our strategy is more centered around what is the gaming ecosystem at the moment, what's it going to be emerging in the near future, and how do we build you a card that you're going to be able to get all the performance and all the features that you're going to actually really use on a day-to-day basis out of that card, and not put in any incremental or additional costs in there that you may not be able to get much value from while you're going to own that card in reality. So to give you an example, had you bought a ray traced card 6 years ago when they first started coming onto the market, how much value did you really get out of that, right? By the time I would say a more reasonable library of games came out that made use of the technology outside of some cool technology demos, you were already on the next generation of the graphics card. So all that money you spent on that first card, you didn't really get a lot of value out of it, from my perspective. So that's one of the reasons we're putting a bunch of ray tracing capability in it, is because we see that the ecosystem is there, and now it's a really valuable feature that you're going to be able to extract and use on a meaningful basis. The third element of it is the machine learning AI capability of it. And why we're putting a bunch of increment or improved performance around that is because of FSR4. And FSR4 will make use of that machine learning hardware, that AI compute hardware, to give you the highest fidelity upscaling experience that we've been able to deliver up to now. FSR 1, 2, and 3 are going to still be around. They're still going to not depend on machine learning and AI hardware to be able to do the kind of upscaling that they do. Yeah. You're going to see the library of those games continue to expand. They're going to continue to work on RDNA 3, on 2, on competitors' hardware, on these amazing PC gaming handheld devices. But FSR 4 needs a lot right now. It needs a lot of AI compute to be able to process the pixels. Okay. So we matched the performance needs of that to with the hardware of RDNA 4.
Okay, yeah, so I guess the next question for me is, does that mean that FSR 4 is going to be exclusive to the 9000 series?
Right now it has to be, because of what I just said. It requires a lot of compute to be able to generate the pixels. It's not that we don't want it to be more compatible across more platforms. Our FSR strategy remains exactly the same on FSR 4 and the future as it has been up to now. We want it to work everywhere, but it's not always possible from a hardware capability perspective. I'll tell you that we are looking at, can we optimize the algorithm so that it can run leaner and it can run on more devices? We are looking at that, we have that desire, but we're not ready to commit and say it's going to go broader at this time. So right now, what we can say is it's going to work on RDNA 4 architecture. They're both built for one another, and we're going to keep looking at seeing if we can go beyond RDNA 4. Beyond RDNA 4.
Could there be a potential path where you have a version of FSR that is dedicated to that kind of hardware, and then a version that is more open?
Well, the more open one is FSR 3, and it's going to continue, and FSR 3.1, that's going to continue. It's development and use, and we have ISVs that are lined up to continue to adopt it into their games. Because as an ISV, you say to yourself, okay, which of these technologies is going to be the most ubiquitous out there that the majority of my customers are going to be able to take advantage of and to get the benefit of? And it's going to be FSR3 because it works on so many pieces of hardware. Us, our competition, N-1, or last generation, prior, 2 generations prior.
Consoles.
It works on some consoles, yep. So people sometimes ask, like, how did you guys get to over 400 games of FSR support? That's one of the reasons why. Number 2, FSR is really easy to implement relative to some of the other solutions that are out there. And we carried that through with FSR4 as well. So implementing FSR4 as a game developer is, I would say, considerably different than other machine learning-based upscalers have been for them to have to implement up to now. TBD on the latest one, we don't have all the details on that, but we wanted to make it easier so that more and more game developers would adopt FSR4 and feel comfortable and enthusiastic about adopting it.
Okay. Can you tell me any preview of like what kind of feature set FSR is going to be? Focusing on FSR4 specifically, like upscaling, frame generation.
Yeah, it'll do both of those, and very similar to FSR3 in what we're accomplishing. It's just the fidelity of it and the quality of it is better. We went as far as we could with a non-machine learning based algorithm up to now, which is FSR 3.1. And it's remarkable if you see it. It is really, really remarkable. But you get to a point where it's like, okay, this is pretty much as good as we know how to get to right now. And I think that's been great for the entire industry because we gave you an upscaling solution that didn't force you into buying a brand new and expensive graphics card. And it's a solution that works on our APUs, it works on our competitors' products. It's a very ubiquitous, amazing upscaling solution. Oh, and by the way, if you want to play a game that isn't in the 400 game library of FSR native support, you also have our fluid motion frames technology, which is an amazing upscaler as well. But you get to a point where it's like, okay, machine learning has advantages, AI, doing real-time AI inferencing of these pixels has its advantages, and that's where what we're going to do is you're going to get better image quality, and it's going to give us, what I would say is in our roadmap of upscaling, there's a point where you can't get further without machine learning, and that's the point we're at now, and you're going to see moving forward, we're going to be implementing more and more upscaling solutions and frame generation solutions that'll make use of machine learning because we're at that point now.
Okay, yeah. Well, I mean, these cards, like you said, they're here, they're close to launch.
They're here.
Yeah,
they're running.
Yeah, they're here, they're running.
They're performing very well.
Yeah, okay, well, let's look at the sticker. What's the VRAM capacity? What's the, can you tell us any more pricing? Is there a sticker that says the pricing on here anywhere?
Yeah, the price is...
Oh, yeah, beep.
Did you get that?
Did you cut? Yeah, I'm sorry.
Look, I think there's a lot of effort internally to make sure that when we announce these products in detail, that the market's going to be happy with them. Okay. What I'd tell you is, with RDNA 3, we had and RDNA 2, we brought some cards to the market that people didn't love the pricing of, and then we brought some cards that people were really enthusiastic around the pricing and the value proposition of it. So we absolutely listen to that feedback, and we're going to do everything we possibly can to make sure that we don't disappoint the market. We're going to try our hardest. So hopefully everyone will be satisfied with the price and the performance. What I'll tell you also is any performance that you've seen prior to CES is not been accurate. So those rumored performance leaks that are out there and things, those are not accurate. So,
meaning better or worse?
You're going to get better performance, and most of the leaks that I've seen, if not all of the leaks that I've seen, you will get better performance actually out of the card. How much better? I'm not going to tell you. And even if I gave you a number, it's like what game and this and that, and then a patch will come out, and then the performance will change, and then I'll get yelled at. So no, I'm not going to give you a number. But but what you should expect is, we've already said we're not going to build a $1,000 graphics card. We're not. This is not going to be a $1,000 graphics card. And the reason is because 90% of gamers buy graphics cards below $1,000. And that's where the majority of the market is. And what we wanted to do is optimize every aspect of every decision that we made on our RDNA 4 so that we're building a gamer's graphics card, something that they're going to get a great amount of performance out of, and they're not going to break the bank in having to get that performance. They're not going to have to overinvest in features that they're not going to take advantage of. They're not going to have to buy into new power supplies or a bunch of power supply adapters and things like that. We just wanted a gamer's card. You can buy it, at a good, reasonable price, get great performance out of it, throw it into your system, and it's simple. It's not complicated. It's a card designed by gamers for gamers with what matters to gamers. The vast majority of gamers that are out there. It's not a tech showpiece. It's not going to be, oh, here's this amazing visual graphics at 15 frames per second that you have to throw an enormous amount of machine learning, upscaling and frame generation to, and to be able to get it to a reasonable frame rate. And it's not going to be a technology demo showpiece in that case. It's going to be a card to play games. And we think that there's still a big market out there of people who just want a gaming graphics card.
Okay, a couple more questions on RDNA 4. I think people are noticing that we're still using the standard PCIe power, no move over to 12-volt 2x6. At what point do you think that those things are going to converge and AMD is going to be like, oh, okay, you know what, we need to adopt that power standard?
Not at this point.
Not at this point. Okay.
I don't know exactly when in the future it'll converge, but I don't think the 12-pin, I don't know if it's not an experiment, but the convergence to 12-pin has gone as smoothly as some folks would have hoped. 8-pin works just great. It works, it's reliable. There's been no issues, no melting components, none of these things, so just go with what works for now. I mean, there's no major benefit. When you look at the risk-reward benefit, there's risk there, that's been proven, and the reward is not really a big reward, so just go with what works. It's simple, it's reliable, and customers don't have to deal with adapters or new cables or new builds or any of those things, and it's been valued by folks just like, okay, just remove, replace, it's simple. I don't have to deal with worrying about an adapter or worrying about if I'm going to go do a new build, can I use a power supply, or does the power supply have the 12-pin connector? It's just another thing to worry about, and the benefit, I don't think it's tangible. I don't think it's worthwhile.
Okay. Last question is around the branding, because I feel like there's this trend at AMD to rebrand stuff every couple of years. Like, you
gotta keep everyone on their toes.
Yeah. So walk me through the decisions on the new branding and kind of break it down for people. I know there's like a handy chart, but we didn't get a decoder wheel this time, so I need some help.
Well, actually, the whole purpose of why we did this is so that you wouldn't need a decoder, because with our prior branding and how it worked, like, what does 7900 mean? What is it relative to the competition out there? Is it like, is it equivalent to a 4090 because there's a 7900 in the number? You don't really know. And then, the pricing is so different from that card. So we got a lot of questions. We got a lot of people going to retail and looking up on their phone. How does this card compare to this card? So the feedback we received is, we don't understand your model numbering algorithm, your scheme. Some people felt it was misrepresentative to brand or to model number something this number. So we're like, okay, look, this is fair feedback. And we went back to the drawing board and we said, can we make this easier for folks? We looked at what we did with Ryzen, and we made it really easy for folks with Ryzen 3, 5, 7, 9. And it's not that easy on graphics because it's a different ecosystem, but we tried to take a page from that and say, hey, if you're in the market now, you can say, I'm in the market for a 70 class card, and the 70 class card costs between this and this in the market, and there's two solutions that are out there, and I know that the 9070 and maybe the 5070 are compared against one another, and then you can decide, okay, let me look up 5070 versus 9070, real simple, right? It's not you have to try to figure out what compares against the 5070. It's just look them up, and hopefully we've done our part to earn your business, but we're just trying to make it a little bit easier for folks. I mean, everyone knows the NVIDIA model numbering scheme. Not everyone knows ours. So rather than trying to educate everybody, and we're just try to create a category of class, like there's Ryzen 5, there's Ryzen 7 classes, if you will, and the competitor has theirs. We're trying to kind of create these classes in graphics to make it just easier for folks.
Okay. That makes sense. I guess more TBD. Thank you for answering the hard questions. I know it's a lot to digest.
It's hard. It's really hard to answer them on Thursday at CES.
I had to think real hard to write down these questions. Like, what should I ask Frank? No, I appreciate it. But let's move over to something near and dear to my heart. We're talking about Z2. So. I love covering handhelds. I've covered a number of them, but the Z2 series has now officially launched here at CES, and there's 3 parts. Can you break down the idea about having 3 parts in the market, kind of the goals of what you want to achieve with it?
When talking about things that we didn't have enough time to put into the keynote,
Yeah.
you notice we didn't even put the Z2 in the keynote. We couldn't fit it in from a time perspective.
Hit my heart.
I mean, I think it's pretty well known how passionate I am about this category. So what we did with Z2 is, it demonstrates our commitment to the PC gaming handheld category. And we're committed to it because it really demonstrates what makes AMD unique, the most unique in the marketplace, which is we have those x86 Zen cores that work across all PC games. Then we have our RDNA graphics architecture, which was designed and developed for discrete desktop and mobile graphics. And we've integrated that, we've fused that into one APU chip, and we've optimized the heck out of it so that you can get incredible performance, but also incredible power efficiency. And that's something we've done on our laptops now for several years, but because we're unique in that in how we do that and our engineering and our capability there, we can also do it in these much thinner, much lighter form factors than even a laptop with different constraints. Weight is even more of a constraint on a PC gaming handheld. Battery life is an even more of a constraint, and it's a huge challenge. So what I'll tell you is this is a new category, and we want better battery life out of it. We want better performance out of the category. We're also seeing devices like the Legion Go to bigger screens, go to more powerful screens. This has an OLED screen on it. It looks gorgeous. I wish you guys could see it in person, but it looks absolutely gorgeous. It's a nice big screen. At the same time, they removed some weight, so it's even more comfortable. So this is, what we're trying to do is help our solution providers, help our OEMs like Lenovo and the others meet their goals for every one of the products that they want to bring out to the market. And they really want to go with us for those reasons, because we're the only one that can give them that performance, that platform compatibility, that discrete graphics level of support and compatibility, FSR support, AFMF support, all these things. But they have different requirements. They may want a certain price point that they're trying to achieve, or they may want a certain performance level that they're trying to achieve. So when you look at the range of Z2, what we did is we put a portfolio together that caters to all of those goals and all of those demands is probably too aggressive of a word, but all of those requests and inquiries that have come into us from the OEMs around, we want something that will help us accomplish this goal, that goal, and the other goal. So the Z2, for example, the Z2 Go is a really well-balanced part from a performance perspective at a price point that's enabling Lenovo to achieve their goals. Then you go into the extreme, which is kind of throw price point a little bit less of a priority and focus on the most amount of performance you can fit into the power envelope and the other constraints that we have to work with in this category. And it's a really amazing part. And what's really, really cool in my opinion is but Valve and Lenovo announced that SteamOS is now coming to more and more of these types of devices. So if the Steam Deck, which is an amazing device, but for some reason you wanted a larger screen or you wanted a little bit more performance out of it, you didn't really have that option before, and now you have that option, but you get to preserve the simplicity of using the SteamOS experience, which is arguably a more seamless and a more user-friendly experience right now than any other operating system solution that's out there for these types of devices.
Well, I think one of the pieces of confusion out there, and I know I definitely had to research it, is that there's 3 different chips, and each one of them has a different architecture, right? I think one way to look at it is like, oh well, it's all named Z2. Why not scale up with the same or scale up or down with the same architecture? Why go with 3 different architectures and call it all Z2?
It's all decisions that we have to make in partnership with the device manufacturers. So some of them come to us and they tell us, hey, price is really important. And older architecture oftentimes enables us to give you a better price for a multitude of different reasons. Other times they come to us and they say, we want something that's a little bit higher performing because they want to differentiate themselves from other things that are in the market. So there you go, and you build the Z2 for them. And then sometimes they come and they're like, what's the best thing you can possibly build? I want to sell a premium device. That's how I'm going to differentiate myself in the market. While others are at $400, $500, $600, $700, I'm going to come in at maybe $999. And the way I'm going to justify that premium is have the best screen, maybe even new battery chemistry that may be at a really high premium but gives you longer battery life and lower weight. And I want the best processor that's possible in this category. So then you go and you build a Z2 Extreme. We don't when it comes to these types of things, we don't build them and then hope that they come, right? We're talking to our device manufacturers and working with them on what are their needs and what are they trying to accomplish, and then we're building the chips for them for those purposes. So when we announce a portfolio like that, it's an indication of things to come.
Okay. And yeah, I mean, there's definitely a bunch of different manufacturers. I mean, from large OEMs to smaller, and you know, I feel like what is it going to take to get to the spot where everyone is using some sort of Z kind of processor? Because I think it can be confusing because you got Z processors that are obviously meant for, you know, this kind of category, but you got plenty of handhelds out there that are using just kind of, I don't want to say off the shelf, but more, you know, just straight laptop oriented processors.
What's interesting is that those handhelds you're referencing, most of them are still using Ryzen, if you noticed.
They're
of not using Z2, but they may be. And that's because we're of all those architectural advantages I talked about earlier. But honestly, whether they're using Z2 or not, I'm not too partial to that as long as they're using AMD, and they should be, because there's nobody else that can do what we're doing right now in this space. Nobody else has the performance, the battery life, and the just x86 PC platform compatibility that we have, plus all the software features like FSR, AFMF, and everything else. So as long as they're using Ryzen, we're good. But you know, the category is an emerging category, and it's something to keep in mind. There's challenges here. You know, I would love to see some better user interface improvements for some of the Windows-based devices, and they're coming, and you know, there's a lot of interest in the category, so we're going to see that stuff evolve over time, just like we saw OSs and solutions evolve in PC gaming over the last 20, 25 years. For those of us that have been around for a while, gaming on a PC 20 years ago was hard. It wasn't easy. Driver issues, API issues, you had conflicting APIs like DirectX and Glide and OpenGL, and some games ran on some of those games ran on some graphics cards that didn't run on other graphics cards. For a while you had DOS and you had Windows, and some games ran on each of the operating systems. You had 8-bit, 16-bit, 16-bit, 32-bit. It was really hard, and it's one of the reasons why PC gaming solution providers like Alienware and Voodoo and all those kind of companies emerged, just because they were building turnkey solutions for people. And it took a while for that PC gaming to be considered a legitimate category for companies to innovate specifically to solve these problems. And PC gaming handhelds, I see it as we're there. You know, there's a lot of potential. It's really exciting. There's a few challenges, like battery life should be better. Weight can always get a little bit better. The OS experiences can be a little bit better. So there's things there. There's a lot of opportunities. And what is really cool about all these other devices that are coming out is everyone's trying to solve these problems. And then at the same time, they're making some mistakes as well, as are we in this whole thing. But we're all just learning together and trying to create a whole new category that barely, I'm not going to say it didn't exist 4 years ago, but it barely existed 4 years ago. And now it
wasn't primary focus.
No, it was like, you know, these devices that in some ways inspired us to create the kind of category that we have today. And they were like the early innovators of this. But it's a very young category of devices, and it's
rapidly evolving.
Rapidly, right? Yeah. I mean, our commitment's pretty amazing. Like to come out with 2-generation processors, Z1, Z2, in what, 2 years maybe? I think it's 2 years. That's pretty. I think that's pretty awesome.
Yeah, definitely. Well, I mean, we talked about Strix Halo earlier. That's a lot of people are excited about that. It's such an interesting product. I think some people were like, "Oh man, Strix Halo in a handheld. Nothing to talk about now. Is it possible?"
If you looked at the CTDP range of Strix Halo, which is how much power and heat it puts out, basically, that would be one hell of a handheld. It is a hell of a chip. But the way you can kind of think of it is so today's technologies should be able to become smaller and lower power with similar performance over time. And that's part of what you see with the Z2 range, is you see some N-1 or last generation architecture stuff in there. And some of those components were higher wattage when they initially came out, higher TDP when they initially came out. And then you refine things, and you work on your optimizations and so on, and then you're able to put them into a smaller TDP package and start offering them in different device categories like this. Maybe that'll happen with Strix Halo over time, but right now it wasn't designed for this. So our design decisions are around form factors like workstation laptops, like okay, what's the most we could put into a tablet, a gaming tablet that's a Z13 with Asus? And then you have some desktops like the HP desktop, and you may see some more coming out that'll make use of the 120 watt TDP range of that device. But one size fits all just doesn't work in this space, unfortunately. So I don't think you're going to see a Strix Halo in one of these devices, but we get surprised all the time. You never know. There was an 11-inch tablet, I think, gaming tablet that was launched at the event. And we've seen devices like that before. Maybe it goes into something like that in the future. I don't know, but I got to tell you, those are going to be some engineering challenges that I'm kind of intimidated just thinking about right now.
Well, do you feel like in this category specifically, AI compute is going to get more and more important?
Yes, immediately, because we're generating more and more pixels using AI, and AI is a very efficient way to generate those pixels. So immediately you're going to see that continuing to emerge. You're going to see it with RDNA 4 like we talked about. And as we get into these devices being able to incorporate in the future more and more of that AI compute capability, you'll start seeing us make use of that AI compute capability more and more in the future. But today, miniaturizing that AI compute and then wrestling with the graphics and the CPU and everything else that we need to wrestle with, and when we design these chips, you're not going to see that level of AI compute in the Z2 generation, not yet.
Okay. Awesome. Well, I'm looking forward to it. I can't wait to get my hands on it. I know some of those people are as well. So thank you. I think we're going to wrap it up and hopefully try to finish our week and get some sleep. But thank you for chatting with me.
Always a pleasure.
Appreciate it.
Thank you for having me.
Yeah, thank you. Thanks everybody for watching. If you want to go back and watch the keynote that we were referencing, click that link over here, like right by Frank. Yeah, somewhere around here.